Hello, good morning. So today we will study uh, spectrum, atomic spectra, and we will also study the Bohr explanation of this atomic spectra. So this atomic spectra is divided. We can divide it into two parts. One is emission spectrum, and absorption spectrum. So what is spectrum? See, when a white light falls on a prism, we got a band of color, right, in the screen. So this is screen. We have different color, na? V I B G Y O R. So violet, indigo, blue, green, yellow, orange, red, na? So this band of colors is called spectrum. Okay. Mm, like this we will get different color, na? Mm, like this. You will see different colors in the screen. Okay, this is not according to the order. Okay, I'm just writing only for example only. See, like this we will get different color on the screen, nah? So this band of color is called, this different color is called spectrum. Okay, or spectra, atomic spectra. This spectra is for white light, nah? So this is visible, na? That is why we are getting we can see, right, different color, na? But in some case uh, there is some spectral lines that we cannot see, okay, with our naked eyes. Okay, here these colors are continuous, right, one after another, na? So this is called continuous spectra. Okay, continuous spectrum. They are continuous, right? But in some case you will see like this, here one line and then gap. Okay, gap, nah, gap, nothing is there, and then you will get one line here like this, nah? So this is not continuous. Okay, like this. So gap is there between them, nah? But here there is no gap, nah, between this color, right? So they are continuous. So this type of spectrum is continuous spectrum, and this type is where there is gap, nah, between any two uh, band of uh, these spectral lines. Okay, between any spectral lines, if there is a gap, then it is called discrete. Okay, the discrete spectrum. So this is for example of color. Okay, just to make you understand what is spectrum. Okay, now suppose in a glass there is atoms, okay, like helium atom, or helium is gas na. So example, helium gas is there, so helium is atom, right? It is also a gas na. So helium is there, okay, helium gas is there. So that means we are taking atoms na. Now when you heat this helium gas with electric current, so radiation will emit, right? And if you place some prism, then here also you will get spectra, okay. Okay, since this is a line line, that is why it is also called spectral lines, okay. Now in this helium case you will not see like this, okay, continuous. You will see like this, okay, like this nah, this one. The spectral lines will be like this, okay, gap, and there is lines nah, like this. You will get spectrum like this. Okay, suppose this is the spectrum, then you will see line, okay, line nah? So in between them there is gap, okay. So this is called atomic spectra, okay, atomic spectra, because we are hitting here what, helium nah? Helium atom. So we are eating helium atoms, so we are getting atomic spectra, okay. It is not continuous. See here, gap is there nah? So diagram you check from the textbook, okay. So here every gas has different spectrum, okay. For helium gas, if we got like this, then for every helium gas the atomic spectra will be same, okay. Like argon nah? For argon it will have different line, okay, like this nah? Example, okay, like this. So all the gas has different spectral lines, okay. So it is just like fingerprints of those atoms nah? Just like us nah? We don't have same fingerprints, right? So like that here also, for all the atoms they have different spectral lines, okay. Okay, see, Bohr could not explain, oh, I mean Rutherford could not explain these spectral lines, okay. He could not explain why we have these discrete spectral lines, okay. But Bohr can, according to Bohr model, he can explain these spectral lines nah? So how did he explain? See, he says that atoms, in an atoms, electron orbit in fixed energy level, right? This is nucleus. These atoms revolve in fixed energy. This electron orbit in fixed energy level, right? According to Bohr nah? So they have some fixed energy nah? Okay, let's say in case of hydrogen atom, hydrogen Z is 1 nah? Hydrogen Z is 1. Okay, we have found out the energy formula nah? Energy, we have derived energy formula, right? It is minus Z score by N score. So energy energy. Okay, this is energy formula, right? Z score 1 by 8 E naught M. Okay, we can copy this one. So energy is this is the energy, na? Energy we have derived, right? This is the energy formula. Okay, here for hydrogen atom Z is 1, na? So that means if you put Z equal to 1, then we will get 1 by 8. Z means 1, na? So E to the power 4 M, the E naught score, H score, N score. And if you put all this value, then you will get minus 13.6. Okay, just put Z score for time being, Z score by N score. So you will get energy formula like this. Okay, now for hydrogen atoms, for hydrogen Z is 1, na? If you put Z equal to 1, you will get En equal to minus 13.6. 1 score is 1, na? By N score. Now this is the energy formula for hydrogen atom, na? For first orbit, there is N equal to 1, na? Second orbit N equal to 2, third N equal to 3, na? So E1, E2, E3. So we can find what is the energy in first orbit, E1, na? So it will be minus 13.6 by N will be 1, now 1 score is 1, right? So this will be the energy in electron volt. Okay, first orbit. And if you do for second orbit also, you will get E2 is minus 3.4 electron volt, and E3 equal to minus 1.51 electron volt, and E4 equal to minus 0.85 electron volt. So we have different energy level, na? Energy for first orbit, second orbit, and third, fourth. Okay, so this is the energy of different orbit. So on heating hydrogen gas, na? Because we are talking about hydrogen. Okay, let's say hydrogen gas, electron absorb, na? Electron will absorb energy and it will jump to the higher energy level, na? So this is hydrogen atom. Okay, so when you heat, then electron will absorb energy and it will jump to higher energy level, right? Because it will gain energy, so it will jump to higher energy level, right? But in higher energy level, electron is unstable, right? In excited state, electron is unstable, na? So it will try to move back to the ground state. Okay, so when it move back to the ground state or lower energy level, it will again release energy, na? So electron falls back to a lower energy level, emitting energy in the form of radiation. Suppose it jumps to, after heating, it jumps to higher energy level here. Okay, by gaining some amount of energy, na? By heating, then it will absorb, this electron will absorb energy, and then it will go to the higher energy level. But in higher energy level, electrons are unstable, so it will again move to the lower energy level, releasing the same amount of energy it gained. Energy of, and it will release energy in the form of radiation, right? Radiation or photon. Okay, so the energy of such photon is equal to the difference in energy of the two orbit. So here in this case the two orbit are orbit 1 and 2, so the difference in energy of these two orbit, okay, will be released, okay, in the form of radiation or photon. So here in this case it is from n2 to n1, transfer from n2 to n1. So energy of photon, E photon, I will write photon equal to the difference of this energy. So it will be E energy of this energy En2. Here energy is En1. En2 minus En1. Okay, I have given you in EF minus EI, final minus initial, like this, right? So energy formula is what? H mu, right? Or H into C by lambda, because mu is C by lambda. So C by lambda En2 minus En1. Okay, from here, see, since energy are fixed, in first energy level the energy is fixed, right? In second energy level also its energy is some fixed value only, right? It cannot have different energy in that orbit. In first energy only fixed energy level electron will be there, right? So these two are fixed, discrete, or you can call it discrete. So that means this lambda is also discrete, okay, so that means this, since these two are discrete, that means lambda will also have a fixed value, okay, discrete value, some specific value, okay. So that is why we see these fixed spectral lines, okay. Lambda, here in this line there will be some fixed value of lambda, okay, and in this line also there will be some fixed value of lambda. Lambda means wavelength, okay, fixed value of wavelength, and here the wavelength are, there is no wavelength in between, right? There is no wavelength, only here we have wavelength, here also we have wavelength, here, and between these two, here we don't have any wavelength, right? This is because of fixed energy, okay, because between these two there is no orbit, no energy orbit, okay. Because of that the spectral lines are also fixed, okay. Specific lambda are there, okay, in the spectral lines. So this is the explanation for Bohr spectral lines, okay, Bohr explanation of the spectral lines. Let's see what is energy level diagram. So this is nucleus, first orbit, second orbit, third orbit, so here n equal to 1, n equal to 2, n equal to 3, and so on, okay, n equal, so I can write like this, okay. N equal to 1, n equal to 2, like this. See, this is energy, okay, energy, increasing energy. So slowly this line will become like this, okay, when you increase the orbit, okay. Let's say n equal to infinity. So this is the first one, nah? So when an electron jump from all the other level to the ground, the first energy level, nah? N, like this, okay, till infinity, nah? So we have some series, okay. This series is called first Lyman series, okay, because they have n n1 is common, nah, for all of them, okay. So when there is n1 common, it is called Lyman series, okay. Second is this one. First is Lyman series, second is Balmer series, okay. This is Balmer series. Balmer series. In Balmer series, they have what, n2 is fixed for all of them, nah? And the next series is when they have n3 same. Next series is Pastin series. I don't have space, that's why I'm not writing, okay. This one, okay, this one, like this, Pastin series. Here n3 is same, okay, n equal to 3 is same, nah? Next is bracket series. So n4 is same, okay, nah? On do this one again, this one is same, like this. And then the last one is Pfund series, Pfund series. Here n5 is same, okay. What is here from this formula, nah? Formula, where is the formula? Okay, here see, this one, yesterday class you correct this one. C by lambda. See here, na, you write, okay, here you rub this one, okay, rub this one, and there you write here C by lambda equal to, okay, C by lambda equal to C mu, nah? C mu equal to this one, Z score E4M, Z score E4M, Z score E4M 8 E naught square 8 E naught square 8 E naught square H cube 1 by n f square minus 1 by n I square. Okay, after that this v mu and this c will go downside. Okay, the same thing you have to write E4 m 8 E naught square H cube and then this c 1 by n f square minus 1 by n I square, and now this mu z score don't write z score, just keep like this. Okay, and then this one is r. Okay, score minus 1 by n I score, and this what is mu? This mu is 1 by, this is 1 by lambda also, or you can write like this, 1 by lambda equal to this one. Nah? Okay, so 1 by lambda equal to, I will take this one. Okay, 1 by lambda equal to this one, z score r, z score r 1 by f minus 1 by I. Okay, this formula we will use in numericals. Okay.